All right, so it's finally time to start looking at the graphs of sine and cosine. So you'll see we're kind of set up to make like any other graph that we've made. We're going to have a table of values, and then we're going to make our graph down below. And we're going to be using those coordinate points from the unit circle to help us. So you may want to go back to your completed unit circle and just put a copy of it over here. I put a copy of my own unit circle so I can reference it quickly. Just might be a helpful piece of advice there. Now remember that unit circle, those coordinate points give us specific information. The x value tell us the cosine of any angle theta, and the y values tell us the sine value of any angle theta. So we're going to be looking specifically at those y values here if we're going to be graphing sine. So the first thing we should do is we should take all of our degrees and remember how many radians each degree is equal to. So for instance, 0 degrees is 0 radians. And if I need a little bit of a reminder, right, I've got my unit circle right there. I can see I've got 30 degrees is pi 6, 45 degrees is pi fourths, 60 degrees is pi thirds. So I'll add those on there, pi 6, pi fourths, pi thirds, and then remember 90 degrees was pi halves because it's halfway to 180 degrees, which itself is pi. 360 degrees was 2 pi. So you can fill this in, whether you have it totally memorized, whether you need to just go right back and right, back and forth between. I like to fill in some of the ones, I call them little benchmark ones for myself, like 3/4 pi, um, for, oops, not 3/4 pi for 273 halves pi. I think that 270 always tries to trip me up. And then I've got my fourths in between. So here 135 degrees is 3/4 pi, and then 5/4 pi, and then on the other side of that would be 7 pi fourths. And then we've got some other thirds and sixths to fill in. So 2 pi thirds, 5 pi sixths, and remember that makes sense because right after 5 pi 6 would be 6 sixths or 1. And then 7 pi 6, let's see, 4 pi thirds, 5 pi thirds, and 11 pi sixths. So however you memorize or compare those radians, figure out a system that works for you, because you are going to want to start to plant those conversions in your head. And notice that our table actually goes a little bit beyond what we're familiar with. I'm going to leave it right now like that. Okay, so let's fill in our sine values here. And again, we already discussed those will be the y coordinates. So if I look at the first quadrant here, I'm going to have a y coordinate of 0, then 1/2, then root 2 over 2, root 3 over 2, and 1. And a little thing that helps me remember that is that these middle values, they're always over 2. Okay, that's one less thing I have to memorize. And hey, what's the square root of 1? Oh, it's just 1. So if I think of this as like the square root of 1, square root of 2, square root of 3, I'm just, So a couple little things in there that might be helpful. So 0, 1/2, root 2 over 2, root 3 over 2, and then 1. And then my next y value starting at 120 degrees. Now it's those same values, but going in reverse. So root 3 over 2, root 2 over 2, 1/2, and 0. Root 3 over 2, root 2 over 2, 1/2, and 0. And now my values are going to be in the negatives. I'll be below that x-axis, so I have negative y values, so negative 1/2, negative root 2, negative root 3 over 2. So you might be noticing a little bit of a pattern here. We're looking at the same values over and over again. And that's That's intentional, right? I mentioned that when we were looking at the unit circle the first time, is that you may not have to memorize 12 different values. If you memorize just a couple, well, you might have everything all sorted out for yourself. So we've got our sine values in our table, and the next step is to graph them. So on your graph, I've got it set up for you where it's labeled in degrees and radians. Going back and forth between those values it's just I'm not going to say it's a terribly important skill. It doesn't come up all that often in real life, but it makes your life a little bit easier when you're talking about trig. So 0, 0, and then I've got 30 degrees, 1/2, 45 degrees, root 2 over 2, 60 degrees, root 3 over 2, and then 90 degrees is at 1. Pi over 2 is at 1. So we're just taking those values and plotting them here. So you can go as fast or slow as you need. You can mute me if you need to. I will promise I won't take offense. Let's see, 7 pi 6, we have negative 1/2. So you might be noticing something just a little bit interesting here, that not only were those values repeating in the table, that now once they're repeating in the graph, they're starting to make this interesting little shape here. So to finish this up, right back at a y value of 0, 2 pi 0. And if I start to connect this, try to make a smooth curve here. I don't want to do this like connect the dots in kindergarten where I'm doing, little line segments. I want to make kind of a smooth curve. And so this looks like the start of my sine graph. Now, I guess my question to you is, what do you think happens at the ends here? What happens after 360 degrees? Does anything happen before 0 degrees? So we can look at our unit circle, we can find those points and we can plot those points, but now when we're talking about the graph, we're going to expand our worldview just a little bit. So on this Desmos screen here, I've got a miniature version of the unit circle, and what's going to happen when I hit play here is it's going to make a graph. It's going to start to trace those y values just like we did when we made our graph. So notice it's got the y values corresponding to the position on the unit circle, and it's starting to form the same graph that we just made. So at pi, it will have a y value of 0, it goes below, and then at 2 pi, it goes back to 0 again. So like I just asked, the question is, what's going to happen after 2 pi? Well, let's think about what's going to happen with the circle. When it hits 2 pi, where is it going to go after that? Well, it's going to keep tracing this circle. It's going to go around and around and around like the world's worst carousel. So what happens to the graph? Well, the graph keeps going in the same exact shape. Up and then down. And if I let it, it would keep going until we asked it to stop. So this is the essence of a sine and a cosine function. It's what's called a periodic graph, where it will make the same shape over and over again. And it will actually do this in reverse. If we think about what would happen if we made the circle go in reverse of its original, rather than counterclockwise, if we made it go clockwise, it would just follow those same exact y values. It's on a circle. It doesn't have anywhere else to go, right? It will follow those same exact y values over and over again. So in the next part of the lesson, we're going to talk about, what those features are, and what's special about them and how do we interpret them further. But from that, I hope we can imagine that now we can start to expand our understanding of degrees and sine values to think about what goes beyond one rotation of the circle. Let's see, this would be 9 pi fourths. And so we get the same y values, we start the cycle over and over and over. So like I said, we're going to explore this a little bit further. For right now, I want to have you take a look at the cosine graph too. Now remember, with the cosine graph, we're dealing with the x values of the unit circle. So I already filled mine in. I challenge you to fill yours in. Fill yours in and make that graph. And think about what are some similarities between the graphs of sine and cosine, and what are the differences, and check back here and we will compare. So as you made your cosine graph, first thing you might have noticed is it's using the same exact values, right? 1, root 3 over 2, root 2 over 2, 1/2, 0. Those are the same numbers that keep coming up over and over and over again. Hopefully that's not too surprising since we saw them on the unit circle. And it keeps going back and forth, 1, 0, -1, and back. A little difference here is that the cosine graph starts at 0, 1, whereas sine started at 0, 0. But otherwise, they look pretty similar, and that's important. It's both important and a little bit confusing. So like I said, in our next lesson, we're going to talk about what are these features specifically, what are the words we use, how do we examine them further. But thank you for your effort here. Thank you for exploring these graphs, and keep up the good work.